Let's talk about one of the most underused tools for modernizing legacy systems: feature flags. If you're working with older codebases, every deployment feels like a gamble. Feature flags change that by letting you deploy code safely to production while keeping new features hidden until you're ready. This is a practical walkthrough based on real modernization patterns. You'll learn how to implement a simple flag system, understand the four types of flags teams actually use, and most importantly, how to separate deployment from release so you can ship confidently, even in fragile legacy code. Here's the problem. You push code Friday afternoon, something breaks, and suddenly you're coordinating an emergency rollback with three different teams. Traditional deployment couples shipping code with releasing features. Every deploy is all in. But what if you could push code to production on Monday, let it sit there dormant, and flip it on Thursday after validating everything? That's the mental shift feature flags enable. Deployment and release don't have to be the same event. Let's make this concrete. Deploy means moving code to production servers. It's just sitting there. Release is when you expose functionality to users. Feature flags split these apart. Code lands Monday, sits dormant behind a flag, and you release it Friday after running integration tests and internal validation. Something goes wrong? Flip the flag off. No emergency deployment, no panicked git revert, no coordination nightmare. Just an instant rollback without touching your deployment pipeline. What does this look like in code? Pretty straightforward. Just a conditional wrapped around new behavior. In this payment gateway migration example, both code paths are already deployed, living side by side in production. Which one executes? That's determined at runtime by a flag you control from outside the codebase. One deployment, two completely different behaviors. You're deciding which runs without touching Git or triggering the deploy pipeline. It's just a toggle. Not all feature flags are the same, and understanding the types matters. Release toggles are your bread and butter. Flip them on, verify everything works, then remove them after a few weeks. Experiment toggles power A/B tests and stick around as long as you're measuring. Ops toggles are kill switches for when things go sideways. These stay permanent because production will humble you. Permission toggles gate paid features or user roles. Also permanent. Different life cycles, different purposes. Same core benefit, control. Here's the simplest implementation that actually works. You need a service that evaluates flags, takes a flag name, maybe a user ID, returns true or false. The interesting part is that evaluate method. You're not just flipping a Boolean, you're hashing the user ID to get consistent percentage rollouts, so the same user always sees the same experience. 10% rollout? The hash determines if you're in that 10%. This gives you gradual, stable rollouts without flickering behavior. Start here. Add complexity only when needed. Here's how you deploy safely in practice. Day 1, flip to 1%. Your internal team sees it first. They hit issues? You know before customers do. Day 2, bump to 5%. Day 4, 25. You're watching error rates, latency, and user behavior at every stage. Something looks wrong? Set the flag to 0%. Instantly. No deploy, no ceremony, no panic. This is how you turn a risky release into a boring Tuesday. Gradual rollouts let you sleep at night. Canary releases. The name comes from coal miners using canaries to detect toxic gas before it killed everyone. Same principle. Route 5% of traffic to your new checkout flow, while 95% stays on the battle-tested legacy system. Watch error rates and latency in real time. If that 5% starts throwing errors or slowing down, kill the flag instantly. The other 95% never knew anything was wrong. You just turned a potential disaster into a contained experiment. Feature flags get really powerful when you move beyond percentages. You can target specific cohorts with surgical precision. Internal teams get the AI recommendations first for dog fooding. Then premium users, who are more forgiving. Beta testers who signed up for experiments. Then maybe 25% of US West traffic before going global. The point is controlling the blast radius precisely. Wrong users seeing the wrong feature? Disaster. Right users seeing experimental features? That's progressive delivery done right. Here's the actual code pattern in action. Your order processor has one method, one feature flag check. If the flag's on for this customer, route to the new microservice. If not, the old monolith handles it. This is the strangler fig pattern. You're not rewriting the world, just adding one conditional. The legacy code doesn't know it's being replaced. Your new service runs in parallel. Things go sideways? Flip the flag, instant rollback, zero deployment drama. Now here's the production-hardened version. You don't just flip a flag and hope. You add eligibility checks and automatic fallbacks. See that try-catch? If the new payment API throws an error, you instantly fall back to legacy. No manual intervention needed. Your metrics capture every success and failure, so you're learning in real time which payments work with the new system. You're not gambling with revenue, you're collecting data, building confidence, and the legacy system is your safety net the entire time. Let's look at Etsy. They ship over 50 times per day, not per month per day, and feature flags make that possible. Every feature ships dark with the flag off. Nobody sees it yet. They test internally with employees, iron out edge cases, then gradually roll out to customers. Once it hits 100% and stabilizes, they clean up the flag. This isn't reckless speed, it's engineered confidence. When deployment doesn't equal release, you can move fast without breaking things. Here's the trap. Flags left in your codebase become technical debt fast. The lifecycle should be intentional. Create the flag, enable it gradually, hit 100%, then clean it up. Delete the flag, remove the conditionals, simplify the code. Best practice? Set an expiration date when you create the flag. 30 to 90 days max for release toggles. If a flag lives longer, it's either a permission flag or debt you forgot about. Treat flags like scaffolding, essential while building, but you take it down when done. Let's cement the essentials. Monitor your flag evaluation. If it's slowing requests, that's a real cost. Test both states religiously, because the off-path always breaks in production when you need it most. Here's the cardinal sin. Never nest flags. 2 flags deep, and your logic branches explode into 16 possible states. Schedule cleanup days monthly. Make it ritual. Flags are powerful precisely because they're temporary. Respect that, and they'll save you. Ignore it, and you've built a second legacy system inside your first. When should you reach for feature flags? High-risk deploys, absolutely. Database migrations, payment flow rewrites, anything that keeps you up at night deserves a kill switch. A/B tests and gradual rollouts are perfect candidates. But here's what flags aren't. They're not your config system. Don't flag wrap pricing tiers or API endpoints. That's what environment variables are for. And don't flag every tiny UI tweak. The overhead compounds fast. Use flags surgically for the scary stuff, not as a blanket safety net. Here's the real power move, using flags to modernize legacy systems without the usual chaos. The strangler fig pattern routes traffic between old and new implementations, testing in production with real users. Branch by abstraction swaps databases or services without touching every call site. And parallel run? Dual write to both systems, compare results in the background, catch issues before they become incidents. These patterns turn months-long rewrites into iterative, reversible deployments. Here's what you need to remember. Deployment and release are not the same thing. Ship your code dark, turn it on when ready. Go gradual, 1%, then 5, then 25. Each step builds confidence and catches problems while they're small. And this is critical. Flags are not permanent architecture. Set a cleanup date, or they'll haunt your codebase forever. Done right, feature flags transform deployment from that sweaty, nail-biting event into just another Tuesday. Let's make this practical. Week 1. Pick your tool. Launch. Darkly. If you've got budget, Unleash for open source, or a simple service wrapper works fine to start. Get flags evaluating and visible in your metrics. Week 2. Take that one feature everyone's nervous about and wrap it in a flag. Deploy it off, flip it on in staging, Feel that control. Week 3, lock in the habits. Name flags consistently, set expiration dates from the start, put monthly cleanup on the calendar. Start small, prove it works, scale it out. And if you want to see how feature flags fit into bigger modernization strategy, watch the next video on the strangler fig pattern. It's the perfect complement to what we just covered.